Alright, this will be the video for Unit 9, Day 5. We are starting to talk about volume, and the lesson today should be pretty simple. Volume is a three-dimensional measurement of the space taken up by a three-dimensional solid. So it's talking about the three-dimensional space, meaning length, width, and height that could fill up a certain figure. Okay? And so for rectangular prisms, it's actually very simple, and even cubes, because all the sides end up being the same. All we have to do is take the length times width times height for volume. Okay, it's the most basic way to think of this. And so to find the amount of area that we would fill up for this, volume, the amount of space taken up in three dimensions, all we have to do is do length times width times height. And you don't even have to worry too much about which one's length, which one's width, and which one's height. You're just multiplying all three dimensions. In this case, we can multiply 9 times 17 times 24. And when you multiply all of those together, you get 3,672, but our unit of measure is cubic centimeters, or centimeters to the third power. Okay? And so I would like for you to try and do 2 and 3 on your own. Pause the video so you can actually try these on your own, get answers for both, and then push play to see what those answers are. Okay, this should be what you get. Should get 630 cubic inches for number 2 and 3,744 cubic feet for number 3. Okay? And that would work for any rectangular prism. Now, that is because this part of the formula, length times width, is actually how we would find the area of what we consider the base rectangle. So really, volume can be very simply put in any prism as the area of the base times the height. And in class, we'll talk about kind of where that comes from and why we decide that that's the way of doing the volume. But basically, we're just going to take the area of whatever shape we have for the base just once and multiply it by the height. Now, it is very, very important that you remember the height is always the distance between the bases. Okay? Remember we talked about this in class. So the bases are always the two congruent parallel sides. So in this case, the bases are the triangles. So the height has to be that distance between those two. So understanding what the bases are is going to help you in a lot of ways. Okay? In this example, we have the top of this rectangular prism, triangular prism. Said the wrong word. Okay, so the base is this triangle. Okay, and they give you actually the dimensions on the bottom. And so you got to be careful that we understand what we're talking about here. Okay, these dotted lines right here make up that bottom triangle, but that is one of your bases. All right? And so I have to find the base area there for finding the volume. And then just multiply it by the height between those bases. Well, the bottom of this prism to the top is this measurement. That's the height, 5 feet. And so the base of our triangle is 1/2 of base times height, or base times height divided by 2. And when I say base this time, I mean the base edge, lowercase b, because I know that it is perpendicular to the height of your triangle along the base. So I'm going to do this measurement, which is the same as its corresponding segment on top, 12, times 7.3 divided by 2. That's the base area. I'm going to take all of that times this 5-foot height. Okay? And then I just do the calculations. 12 times 7.3 divided by 2 times 5. Okay, I'll kind of skip over some of that and show you the shorter way of saying that. The base area, this part in parentheses, does give you 43.8. So we're going to take that times 5, and we get 219 cubic feet. Okay? So I'd like for you to try and do number 5. Pause the video to give yourself some time to do that. Okay, but try it on your own, and this is the answer that you should get. All right, you may have an answer. This isn't obviously your final answer yet. I did want to actually tell you to make sure to point out the distance between the bases is the height between the bases, and that in this case is 16. The bases of the triangles at the front and the back, so the distance between them is 16. So this h should be 16. When you find the area of this triangle for the base, area capital B, you're going to use this height of the triangle, 5.4. All right, and this is what you should get. 475.2 square millimeters. The base area is 29.7, and so when we multiply that by 16, we get that. Okay? And then really it's just the same process repeated over and over, but the bases change shapes, and so we need different area formulas for the bases. So in this case, the volume of this trapezoidal prism is the base area of one of these trapezoids times the height. Again, height is the distance between the bases. So this is my base. The other trapezoid behind it is the other base. This is the height of your prism. Okay, so we're going to do our area formula for trapezoids times that 25. Well, the area formula for a trapezoid is base 1 plus base 2. Okay, because if this is 36, so is this segment. Base 1 plus base 2, all times the height of the trapezoid, which is this, divided by 2. So again, height times the sum of the bases, all over 2. I'm kind of writing small, I'm sorry about that. Zoom in if you need to. Okay, so when I work all this out, I get that the base area of the trapezoid, this part in parentheses, becomes 447.5, and then I need to multiply that by the height of 25 meters. So you will notice they give you some information that isn't necessary. We don't need this length of 21. And so when I work those out and multiply it all out, I get a total of 187.5. This is in cubic meters. Okay? So let's take a look at cylinders now, and it works out in very much the same way that prisms did, because cylinders are just prisms with circular bases. Okay? Now, I'm skipping over examples 7 and 8, all right, to numbers 9 and 10. If this is a cylinder, notice that it's a prism where the bases are just circles. And so your formula is this, but I want you to pay attention to this first part, pi r squared. Pi r squared is the area formula of a circle. And so the base area is pi r squared times the height. So it's still volume equals base area times height. But in this case, the base is a circle. Okay, so volume here is base area times height, or more specially for cylinders, we can call it pi r squared times the height. And remember, height is the distance between the circles. So in this case, that's your height, 15. So we're going to do pi times the radius of 18 squared times the height of 15. Remember to do exponents before multiplying. And we're actually going to do all of this before multiplying by pi. Okay, when I do 18 squared times 15, that part of the answer is 4,860, but then I still have to multiply by pi. And so when you multiply 4,860 by pi, we get approximately 15,268.14, and the unit of measure is inches, so this is cubic inches for our volume. Okay? All right, we're going to do number 10, but I'm going to let you pause the video to try and do this yourself. The volume in this case, again, is pi r squared times h, where r is the radius of the circle, and h is the distance between the circles. So in this case, I want you to recognize h is 21, and r is not 11. 11 is the diameter of the circle, so the radius should be 5.5. So I want you to plug those in and come up with an answer, and pause the video to give yourself time to do it, and this is what you should get. 1,995.7 cubic meters. Okay? So we're going to take a look at some of the application problems. All right? And these are some areas where you might end up using volume in some of your calculations later on. Okay? Number 11, a cylinder has a 2 centimeter diameter, and that cylinder is drilled through this triangular prism. And so we want to show the volume of the prism after that has been drilled out. Now what that means is we're going to take the volume of the prism and subtract the volume of the cylinder. Okay? So we're just going to use those two parts. Remember, volume of a prism is base area times height. Now it's hard to see, but this angle between the 5 centimeter segments in your triangle is a right angle. That means that the base edge of your triangle is 5 and the height edge of your triangle is 5, but the height of the prism itself is the 14. Okay? So what I'm trying to say is this triangle on top really looks like this. Okay? And obviously there's a hole drilled through it, but we can include for volume this whole triangle for the base area. So we're going to do base edge of 5 times the height of that triangle 5, all divided by 2, times the height of the prism, 14. But I'm going to subtract the volume of a cylinder. Now, it doesn't tell you a whole lot here, but remember it says a 2 centimeter diameter is that. So if the diameter is 2 centimeters, the radius is half of that, or 1 centimeter. So we're going to do pi times that radius of 1 squared times, again, the height of your cylinder, the whole 14 centimeters. And then we're going to simplify all this, and that'll be our answer. Okay, for this part, 5 times 5 is 25. 25 times 2 is 14. Okay. I'm sorry, 25 divided by 2 is 12 and a half. And then multiply that by 14. I get a little confused. I'm sorry about that. So the volume of your prism, before you take out that hole through the middle, is 175. And then we're going to subtract 14 pi, because 1 squared is 1. 1 times 14 is 14. Okay? And so we're going to say that that part is approximately 43.98. So when I do 175 minus 43.98, I get my total volume equal to 131.02 cubic centimeters. Okay? All right, and we can actually finish this out and do number 12. The more examples we do, the better. So we've got a diagram for Eric's pool. He plans to fill his pool to a depth of 4 feet with a garden hose that has an 80 cubic foot per hour flow rate. How many hours will it take him to fill up the pool? So we need the volume of water he's going to end up putting in there. Now, he said he's only going to fill it to 4 feet. So even though the tank or the pool is 4.5 feet, we're only using a height of our cylinder of 4 feet, okay? Because I want the volume of water in cubic feet, or feet cubed, so I can know how many hours it's going to take. So the first thing to do is to find the volume of that pool. Okay, again, using the volume of a cylinder, pi r squared h. Okay, now it gives you the diameter of the pool, so the radius is half of that, or 13.5. So we'll do pi times 13.5 squared times the height of 4, not 4.5. This is only going to fill the pool to 4 feet. Okay, so when I work all that out, okay, 13.5 squared times 4 is 729, and then pi, which is approximately 2,290.22 cubic feet. Now, it fills at a rate of 80 cubic feet per hour. So I need to divide that amount by 80 to find out how long it will take in hours. And when I divide that out, I get approximately 28.63 hours to fill the pool.